Okay, so today I want to start with introducing radian measures by showing you the actual unit circle. Again, all filled out. We've been working on how to build this unit circle, and of course the equation of the unit circle has an x squared and a y squared added together, and x squared plus y squared equals the radius squared is the equation of a circle at the origin, and since the radius is 1, 1 squared is 1. So the equation of the unit circle does tell us its radius is 1. So you can already do certain things on this unit circle, and you can recognize 30 degrees, 150, 210, and 330 are all on that chart, and they all reference 30 degrees. You can see 45, 135, 225, and 315 all reference 45 degrees. And then, of course, the 60 degrees, the 120s, the 240s, and the 300s are all 60 degrees away from the x-axis. So there's some lovely symmetry going on there. You also know ordered pairs. You know that as x goes down from root 3 over 2 to root 2 over 2 to root 1 over 2, y's go up. 1 over 2, root 2 over 2, root 3 over 2. And that pattern, of course, follows through with the other quadrants. The only thing we did have to remember is that the signs in quadrant 1 are positive. In quadrant 2, the x values, you'll notice, are all negative and the y's are positive. In quadrant 3, they're both negative signs. In quadrant 4, the x is positive but the y is negative. So we remember that when we're doing our sine, cosine, and tangent problems. So what don't you recognize on the unit circle here? You probably don't recognize these right here, okay? So these numbers, well, some of those we might recognize. Let's see. We definitely recognize 0, okay? So 0 degrees is the same as what they call 0 radians. If I went a full rotation, this 0 degrees is coterminal to 360. And in radians, a full rotation is 2 pi radians. So if I said, what's the cosine? Let's say I said, what's the cosine of 360 degrees? You can answer that because you know cosine is x, and at 360, x is 1, so the cosine of 360 is 1. But now if I say, what's the cosine of 2 pi radians, you can now answer it knowing that 2 pi is 360. So basically, it's still landing at the same spot as 360, and so the cosine is still 1. So if you have to, you're going to have to actually memorize this. So you have to memorize that 360 is 2 pi, or maybe it's easier to memorize that 180 is pi, okay? So if everyone starts by memorizing 180 is pi, I can ask you right now, what is the, we'll do cosine of pi. Well, the cosine of pi is the same exact answer as the cosine of 180, because 180 degrees is equal to pi radians. You'll notice with radians, I don't have any kind of label. So we do have to assume that if there is no label, it's in radians. That's why we always put a degree symbol for degrees. All right, so the cosine of pi. Well, cosine is x, pi is 180, and x is negative 1 there. And so you can see how you would fill in your answer. All right, so knowing that 360 is 2 pi and 180 is pi, we can go back and start to think about all these other angles that they give you in radians. All right, so I'm going to do that on the next page. Now, you are memorizing that 0 degrees is 0 radians, and 360 degrees is 2 pi radians, and 180 degrees is pi radians. Now half of 180 you should know is 90, so half of pi you can just say is pi over 2. So if you start counting, pi over 2 is the same as 1/2 pi. 1/2 plus 1/2 is 1 whole. 1/2 plus 1/2 plus 1/2 is 3/2 pi. And that we already knew was 270 degrees. And if we were to go one more, 1/2 plus 1/2 plus 1/2 plus 1/2 is 4 halves, and 4 halves we know is the same as 2 pi. So this was the 3 pi over 2 because there were 3 halves, and that's the same as 270. And 4 halves is the same as 2 pi is 360. So if we know 180 is pi, how do we get to 45? Well, you could take 180 and divide it by 4. 180 divided by 4 is 45. So if 180 is pi, then 45 is pi over 4. It also works if you start at 90. Half of 90 is 45, and half of a half is a quarter pi. So that's another way to see that 45 is pi over 4. Now if you start counting by pi over 4s, this is 1 quarter, 2 quarters is a half, 3 quarters pi. So right here you have 3 quarters pi. And we already knew that to be 135, I believe. And 4 quarters pi, right? 4 quarters pi would give you right back to a whole pi. So this one was 3 quarters of a pi. Okay, 3 quarters of a pi. And so this was 1 quarter, 2 quarter, 3 quarter, 4 quarter. Now we're going to do 5 quarters. So you can say 5/4 pi. This one is 6/4, and 6/4 reduces to 3 halves. And this one would be 7/4 pi. And 8/4 takes you right back. 8 over 4 is the same as 2 pi. All right, and the angle measures, of course, were 180 plus 45. It was at 225, I think. And we had 360 minus 45. Okay, so that's how you're getting these radian measures right here. 45 is a quarter. 135 is 3 quarters, because this is 2 quarters, and 2 quarters is a half. And here's your 4 quarters. So we have 1 quarter, 2 quarter, 3 quarter, 4 quarter, 5 quarters. 6 quarters is 3 halves. 7 quarters and 8 quarters is 2 pi. So that's how they're getting those numbers. And what I would like you to try to do is try to fill it in by 30s. If you start going by 30s. Now, 180 divided by 30 is 6. So that's why pi divided by 6 is pi over 6. So 30 is 1/6. So 60 is 2/6. And 2/6 is the same as 1/3. 90 is 3/30s, so 3/6, which is the same as, of course, pi over 2. 120 is another 30, so that's your 4 over 6, which reduces to 2/3. Here's your 5/30s, so we have 5/6, and then we have 6 over 6, which of course is a whole. So it just doing that 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. So anytime you need to move 1 down from 6/6, you know it's 7/6. And if you have to move 1 up from 6/6, you can see it's 5/6. So kind of keep that in your mind as you're thinking about these. And so as you keep going, we have 1/6 pi, 2/6 pi, 3/6, 4/6, 5/6, 6/6. So here is our 7/6 pi, our 8/6, which of course reduces to 2/3 pi, our 9/6. So you can see it works every time if you're doing it right. 10/6 is the same as the 5/3. 11/6 you can't reduce, and then 12 over 6 is the same as 2 pi. So that's how you're really filling in, or at least that's the more middle school way of thinking about it. There is a ratio that you can always take any angle, let's say 30 degrees, and multiply by pi over 180. It's a trick that the degree measures would cross out, and basically you would get pi over 30 over 180 reduces to pi over 6. So you could do this for any degree measure. 150 degrees, you can multiply by pi over 180, and it will convert it into radians for you. The degrees cross out, and you get your 5 over 6 is what 150 over 180 is with a pi. So you can do that if you wanted to convert degrees to radians. And if we wanted to take a radian like 3 pi over 4 and convert it to degrees, you just multiply by the reciprocal, 180 over pi. Because then the pi's cross out, and 3/4 of 180 is 135. So that's a way to convert backwards to degrees. And so really the goal was just to introduce a radian to you today, though. So in terms of introducing a radian, just remember that if 180 is pi, you should be able to fill in any of these. For instance, if we were to try to do it, let's say if 180 is pi, remember 90 is pi, half of that, right? And 45 is half of a half, which is a quarter. Do remember when you get to 30 degrees, 30 degrees is 1/3 of 90. And since 30 is 1/3 of 90, 1/3 of a half is a sixth. And 60 is then going to be a third. Because if 30 is 1/6, 1/6 plus 1/6 is 2/6, and 2/6 is a third. So keeping those in mind, if I wanted to do 150, I know 150 is 30 away, and 30 away is pi over 6. So I can make this 6/6 and take 1 away is 5/6. If I wanted to do 135, I know that's 45 away. So now I'm going to know it's 45 back. So 45 is 1/4. So I'm going to think of it as 4/4 and take 1 back. I have 3/4 pi. Okay, and it does work. Now, if you want to do 120 by saying 2/60s, 2/60s is 2 pi over 3s. You can also do it that way, 2 pi over 3. So there's a bunch of ways to do these. If I wanted to do 30 away from 180, 30 is pi over 6. 180 is 6/6, so I should know this would be 7 over 6. If I wanted to do 45 away, which, I'm sorry, the 30 away was 210. 45 away, 45 is a pi over 4. So think of it as 4/4 plus 1 more fourth, and you get your 5 pi over 4. Okay, and 60 away from 180, 60 away from 180, use a 60 as pi over 3. So think of this pi as 3/3, and 3/3 plus 1 more is 4/3. So that is another way to get these, and I would like you to try to fill in these last 3 dots yourself. All right, so by now you did from 360 down 30 degrees was 330. And since 360 is 2 pi over 6, since 360 is 2 pi, and 30 is 1/6, we're basically doing 2 pi take away a sixth. And now 2 pi is 12/6, so 12/6 take away 1/6 is 11/6 pi. If we were to instead try to go 45 degrees down, 45 degrees from 360, we would be at, 315? So remember 45 is pi over 4, and think of this as 2 pi is 8/4, so 8/4 take away 1/4 is 7/4 pi. 7 pi over 4 or 7/4 pi. And then when we think of the last one that references in quadrant 4 an angle, this one references 60 away. So 60 away would be 300. And since it's 60 away is pi over 3. So if you think of the 2 pi as 6/3, 6/3 take away 1/3 is 5/3.